electrode, electrode potential. By taking example, copper metal placed in copper sulphate solution, aqua solution, whose concentration is 1 molar. So, if you take one container and in this container take copper sulphate solution, aqua solution, its concentration is 1 molar concentration. And in this copper sulphate solution, we are immersing a pure copper metal plate is placed in the solution of copper sulphate solution, salt solution. Okay. When a solid metal is placed in the copper sulphate solution, aqueous copper sulphate solution, solid liquid interface will happen. Due to the concentration of copper sulphate solution, the copper metal plate interact with the solution. As you know that copper sulphate solution contain cupric ions and sulfate ions, where cupric ions have deficit of 2 electrons. They try to obtain electrons from the copper metal plate. So copper plus 2 ions gain 2 electrons from metal plate and get reduction to solid. That means copper electrode provide electrons to cupric ions. That means the surface of the copper plate having negative means surface of the copper metal will provide 2 electrons and then cupric ions get reduction. That means copper plate loses electrons. Copper plate loses electrons. That means here when the cupric ions get reduction, copper atoms being deposited on the surface of the electrode, copper metal atoms are deposited on the electrode, but inside the copper metal, copper atoms loses the electrons. As a result of this, copper metal gain positive charge. That means cathode gets positive charge. So now this electrode is a cathode, carries positive charge. Because copper metal atoms lose electrons and given to cupric ions in order to cause reduction. Now cupric ions aqua solution gain 2 electrons and get reduction to copper metal. The copper metal atoms deposited on the surface and give a negative charge over it. Negative charge. You can see negative charge being formed on this metal plate. Now at this point there is clear charge separation. So on the copper, inside the copper there is positive charge and the surface of the copper metal is negative charge. So negative charge layer and the positive charge, and between this charge separation result potential, electrode potential has been generated. This electrode potential we measure in terms of volts. Electrode potential we measure in terms of the volts. 1 coulomb per second that pass through the solution is a volt, we say. So that electrode potential is due to the metal plate in the copper sulphate solution. Hence it is said to be single electrode potential, and this single electrode potential due to accepting of electrons, which is called reduction, So now this single electrode potential is said to be reduction electrode potential. Reduction electrode potential takes place in another half cell of electrochemical cell. It is a part of the electrochemical cell. It is a half cell of the electrochemical cell. It is not complete cell. So there is reduction electrode potential that takes place in the cathode electrode. At the cathode electrode, there is oxidation electrode potential that takes place in another half cell of the zinc metal placed in the zinc sulphate solution. So now this reduction potential when it is measured at standard conditions like 298 Kelvin temperature, 1 atm pressure if you measure, then this reduction potential is said to be standard reduction potential, SRP, standard reduction potential, we say. That means the concentration of solution must be 1 molar and copper plate must be pure, and temperature must be 298 Kelvin temperature. Pressure is said to be 1 atm pressure. The electrode potential generated in this half cell is said to be a standard reduction potential, we say. The standard reduction potential and standard oxidation potential takes place in two half cells. So after this, next we are going to discuss about standard cell potential and cell potential. So what is the cell potential of the electrochemical cell, galvanic cell, we'll discuss now. Of course you understood this one. Cupric ions get reduction on the surface of the copper metal and gain the electrons, that causes reduction. And one thing you should observe here, cupric ions after some time, their number decreases in this half cell. When the cupric ions number decreases, but cell potential of electrochemical cell decreases. At the same time, in another half cell, at the anode, the zinc ions number increases. So in another half cell, number of zinc ions increases, and in this half cell, cupric ions number decreases. At this time, the cell potential halts. The cell potential doesn't work. That means EMF equal to 0, it doesn't work, cell doesn't work. Then at that time, what we have to do? Then we have to introduce salt bridge. So let us discuss cell potential. What is meant by cell potential? What is meant by standard cell potential? So we'll discuss by taking electrochemical cell.